So I wanted to do a quick survey before I jump in. How many people here have had a conversation at their organization, either they're the ones giving it or the ones receiving it, saying, we have a lot of data, I think we can do some machine learning on it? Quick show of hands. So how many people were the receiving end of that conversation? Great, a few. And what did you find when you actually started to look at the data and the problem? Was it possible to do the machine learning that was being recommended? No. Okay, I have two slight nods back there. That's quite good. So that's what I want to talk about today, is how we can actually turn those kind of leadership visions of using the data that we have and making that actually work. And I'm not going to be talking about data science, detail math, or tech. We had quite a bit of both already. So what I want to be talking about today, coming back to the original problems we were overviewing, how do we get that training data that's usually missing? How do we improve business rules, provide context to the data scientists, interpret results, and realize benefits? Now, all of those problems that we're addressing are going to be addressed by a very simple solution. They're not all solved by that simple solution. It's not a panacea, but I think it is something that's quite interesting. Now, coming back to the problem of connecting data sets, connecting records, the Office for National Statistics has one of the biggest challenges in this space. So they need to create a unique list of businesses that they can use to produce sampling frames, they can go out do business surveys, they can actually produce their statistics. Now, I'm not going to go into all the data sources, but you can imagine there's quite a few different government systems that holds data about businesses, and you need to connect all of those together to be able to do surveys correctly. So there's millions of different records, and when you start to look at the many-to-many connections and the different ways you can measure similarity, that's trillions of potential links. So for the last 40 years, probably more, there's been teams of people and business systems using a predominantly business rule-driven approach, but also a lot of statistics. And in the last 3 years, the Office for National Statistics has started to take a bit of a transformational approach, looking at how we can do that with machine learning. And they had the same conversation 3 years ago where they said, okay, we have a lot of this data, we certainly have a lot of qualified people, how do we use that to actually generate a machine learning solution? And the approach that they took is somewhat similar to the one that I'm going to describe following slides as well. So the main thing to think about here is that they employ data scientists in the new 21st century definition of those who can do big data engineering, those who can do the big data statistics. They also have a lot of qualified people who are, in every sense of the word, still data scientists, but maybe closer to statisticians, maybe using different types of systems that don't necessarily allow the use of lots of data as much. There's also a lot of people who are maybe closer to data analysts who are manually assessing whether certain records are meant to be linked together. So there's a whole lot of business context sitting there with people who don't necessarily have the tooling and the skills to be able to do the data science themselves. So the challenge is, how can you do kind of a Freaky Friday brain swap between these two groups of people, those who have the technical skills and those who have all the business context. So I'm not going to talk about Freaky Friday type scenarios. I am going to talk about how we can use non-data scientists to be involved in the data science process that I did an overview of before. And the main idea here is to think about, how is training data usually created in your organizations? Because usually it's not necessarily a focused, targeted act where we're trying to build training data. It's often organically built up over time. Maybe some people had done it for a certain use case and they're starting to build those out. But when we look at the actual productivity of the people who are building that training data, which is needed to do the machine learning, it's very unproductive. They're not doing it in the easiest way possible. So at the Office for National Statistics, they built a very lightweight tool. It's not this one that you see here, but it's similar, a lightweight tool where you could quickly look at two records, and this is a non-data scientist with the 40 years of context, being able to say, is this the same? Should that be a link? And then a quick set of buttons here, maybe some context. They're able to understand what the overall set of links might be. They're able to see the different attributes that they're trying to compare. You can see in this example, which does not apply to any specific business case, but attribute 4, it's obviously quite different, big versus small. Attribute 1, it does look fairly similar. Potentially attribute 8, it could be the same person. Now, these types of attribute similarity applies to all the problems, not just customer type connections, but also different systems might have a different primary key added at the source from a different vendor. By the time your outsourced vendor operations get into your central data store, the primary keys have been malformed potentially. So these types of record observations can be applied to almost every situation. And what you get out of it, as you might expect, is a very productive way to create training data. So you click that button, it automatically populates the next one, you're looking at it again. There certainly is some tooling you need to set up, but in the case of using, let's say, an Excel front end, which can easily accommodate that, we're talking about a day or two of someone's time to build that lightweight tool. You're determining what data will go in and feed that. But it can be a great way to actually scale up the data science effort. And just to put it in perspective, there's a lot of data scientists who are trying to do this themselves. They don't have an easy-to-use tool. They don't have the context. Frankly, they're well overpaid for that task. They should be focusing on the pieces of that data science pipeline that only they can do, and we should be scaling up how we can get the training data. Now, this is not a new idea. We're going to talk about it in a slightly new arena, but right now, there is a big data center in Kenya that there's people who are dragging and dropping and identifying where there's vehicles in lots of still images and video. Now, this is feeding into an intermediate organization called Samasource. That's where I pulled this idea from. There's a recent article written about it. But this is essentially feeding into Google Car, likely into some of the other autonomous vehicle programs that are there. So there still is a human in the loop. It's being outsourced. It's being scaled. There's lots of other examples where Amazon's Mechanical Turk, maybe some of you have used this or know about this, where again, lower cost resources, usually lower skilled types of activities are being outsourced, and you're able to get a lot of quick feedback. I think the one that we've all done is identify the 15 signs so you can get into your bank account type of Google login process. It's something similar, but tasks like that. So you can do it too. That's the main thing. That this isn't very difficult to do. You do need to have a different approach, and you need to figure out a way to get people involved at the beginning, but it can be transformational. And I want to talk about how it's transformational in a few different ways. So I am looking at a slightly data science problem here, so bear with me for a minute. The task here is you've got two dimensions, variable A and variable B, and you have some of your data sets are your training data. You've already positively identified that this is a black and this is a yellow, and the goal is how do you predict these non-colored, not in your training data set, what color they're meant to be. So that's the general problem. It's simplified in lots of different ways, but one of the algorithms that you can use is called support vector machines. Again, in a very simplified way, it's trying to find what angle of the line and where the line should be placed so that you could say anything above the line is a yellow in this case, anything below the line is a black. Very simplified way of thinking about a data science problem. Now, if you're a data scientist, what would be fantastic is to have as many of these filled as possible. And that comes back to the original, how do we scale up creating training data? And that tool can help there. But once you actually think about what this process is, how you're deciding which of these data points you're going to have your non-data science staff actually decide what category they should go into, there's a lot of intelligent thinking you can put into that process. So the reason why I've tried to create a bit of a highlighting here is that these non-filled in ones here are the main problems. When we try to do classification, we try to do that prediction, these are the ones very likely we're going to get wrong. So we probably want to put a lot of focus into that non-data science tool of those that are on the decision barrier. And this is going to be different depending on which machine learning algorithm you use. There's lots of other ways to think about how we're choosing them. But the main idea is, can we put a lot of thought into that? And then also, can we be focusing on these that seem like potential outliers? They may not be outliers. It's possible it's not a support vector machine. It's possible we need to do random forest, just to throw out all the words we like to say. But we could be focusing on those ones as well. So there's a way to data science this metadata science process and really improve it. But that isn't the biggest benefit. It certainly is exciting for data scientists who are sitting on the other side of that conversation and know that half of your data is not filled in and the training data actually is misunderstood and you only have 100 records, so you can't possibly do machine learning. I probably deal with that conversation once a week. The real benefit here is the mind meld that you're going to get, the type of behavior that I was trying to describe before of non-data science context being into a data scientist's brain and the reverse. So what you really get is, if we go back, actually, I'm just going to go back because I think it's a little bit easier looking at this. We go and we assess that. Now, they look at it and they say, oh, you know what, it's not a yes or a no, obviously, it's a maybe. And they go back into it, they start looking at it, and they probably understand maybe our business rules aren't right, maybe we've identified a problem with the data, and now you start to see all these other benefits coming out of it, not just this one problem, but you're also looking at the entire data pipeline from raw data, all the QC checks you're doing at the beginning, and you're starting to get what I would call organic innovation, where you don't have to have a program saying let's improve QC. You're actually saying we're going to find these things out because now we're starting to have those discussions, we're starting to have those informed discussions about it. But going back to the Spock mind meld, a huge part of what we at Alchemy like to focus on is raising the general data literacy of any organization that we're working in. There's a lot of benefits to having a leadership team who understands what an error bound actually means. There's a lot of benefit to having non-data scientists understand how their activities and efforts upstream in the data pipeline are going to lead to poor data and poor decision making down the line. And what you get is a general data literacy is starting to go up. You have the non-data scientists understand what's important to a data scientist, and just as importantly, a data scientist starts to get answers to questions that they couldn't possibly have known to ask. They didn't realize that this business rule was malformed in this way, or that this business is operating in this other department. And those start to come out of this process quite a bit. And then I would say the last thing is actually, once you start to recommend, yes, these two things are connected, and now you can make this investment in this business decision, it's always difficult for anyone who doesn't understand the detail, maybe doesn't understand the math and the tech that's behind it, to say, good enough, I'm going to put £1 million down on this bet. But now once you have a wider data literacy, everyone understands what the process is, it's quite transparent, as you can imagine, you're able to make better decisions, more investment.